Hey guys, welcome to Pre-Calc lesson 6.7, Hyperbola Equations. Convert from general form to standard form, find critical values, and sketch. And that is pretty typical of what you can expect to see at the end of the unit on the exam, review, work session, so on and so forth. It will not specifically tell you what type of conic section it is, and it'll say find critical values. So we just need to have an understanding of what is expected and what type of conic section it is in general form. So what I notice here is that A does not equal B and that they have different signs. So that tells you it's a hyperbola. Okay, so now I need to get it into standard form. Well, hyperbolas are a little bit challenging to get into standard form, and you'll see why here in a second. First, let's group our x's. X squared minus 8x, give yourself some room to complete the square. Group the y's, negative 4y squared plus 16y. Add 36 to both sides, right? Undo that, so it's adding 36, positive there. Here's why hyperbolas are a little bit challenging. There is no GCF with the x's, so I can just rewrite this as x squared minus 8x. But the GCF I need to take out with the y's is a negative 4. Notice I need to take that out. I need to have a positive y squared on the inside. So this will give me y squared minus 4y, and all that equals 36. Okay, complete the square on the x's. Half of 8 is 4. 4 squared is 16, so I add 16 there, add 16 there. Remember, there's no GCF. I don't have to multiply 16 by anything. Complete the square on the y's. Half of 4 is 2. 2 squared is 4. Now, what are we really doing here on the left side? I'm not adding 4, and I'm not adding 16. I am subtracting 16. So to keep it balanced on this side, I need to subtract 16. And that's why hyperbolas are tricky, because we always have that negative we need to deal with. All right, so writing the equation from here, I'm going to have x minus 4 squared minus 4 times y minus 2 squared equals 36. Remember, standard form is equal to 1, so I'll divide both sides by 36. And that will give me x minus 4 squared over 36 minus y minus 2 squared over 9 equals 1. And there's your standard form. Okay, what I like to do now is recognize, x squared is positive, so it's a left-right hyperbola. And I make a quick little thumbnail sketch so I know that my hyperbola on the grid will look like that. And then I go ahead and quickly get the 3 pieces of information we always get. Center, x pole, y pole. So my center is going to be 4, 2. X pole is the square root of 36, or 6. Y pole is the square root of 9, or 3. And that's more than enough information to graph this hyperbola. All right, so the center is 4, 2. 1, 2, 3, 4, 2. There's my center. X pole is 6. So 1, 2, 3, 4, 5, 6 right there. 1, 2, 3, 4, 5, 6 the other direction. Y pole is 3. And those basically are the midpoints, we said, of the opposite sides of a rectangle. So let's sketch in that rectangle. And we use dotted lines or dashed lines for these because it's not part of the graph. Next, I sketch in the asymptote lines. So it looks like the slope is up 1 over 2. Okay, now look at your thumbnail sketch. It's a left-right hyperbola, which makes this a vertex, and it makes that a vertex. So your hyperbola approaches the asymptotes but does not intersect. Okay, so I've identified the coordinates of the center. That's one of the key points I need to identify. I also need to get the coordinates of the vertices. Those are easy to get. Nice integer values. You can use your grid. That looks, V1 looks like it's negative 2, 2. V2 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2. need to get two more things. The coordinates of the foci and the equation of the asymptote lines. It doesn't really matter what order you do this. I'll do the asymptote lines first. So for my asymptotes, remember, it's pretty easy. It's going to be y minus the y coordinate equals plus or minus y pole over x pole, x minus the x coordinate. Right? We use point slope form of a line. So it's y minus 2 equals plus or minus y pole over x pole. Again, you can simplify this, or you just leave it plus or minus 3 over 6. I don't care. X minus 4. That represents the two equations of these asymptote lines right here. Okay, and lastly, I need to get the foci. So let me do that. For your foci, remember your equation is going to be c squared equals a squared plus b squared in a hyperbola. So that's going to be 36 plus 9, and what's that, 47? No, sorry, 45. So c equals square root 45, which is 3 radical 5. For graphing purposes, that's approximately, 6.6, let's say. So to plot those, I have to go from the center right just beyond 6. So it's going to be here, that'll be F2. And left just more than 6, that'll be F1. To write these coordinates, we need to put them in simplest radical form. So again, this is where it's helpful to understand what we're doing. This distance from the center to the focus is what we call C. In this case, that's going to be 3 radical 5. So I'm taking the x coordinate, because I'm going to the right. I'm taking the x coordinate of the center and adding 3 radical 5. That gets me this one right here, F2. F1 would be the x coordinate minus 3 radical 5. Okay, so it's 4 minus 3 radical 5, comma 2. And this one would be 4 plus 3 radical 5, comma 2. And remember, when we're done, the foci and the vertices should have the same y value. Why is that? Because they're on the same horizontal. Remember, the foci and the vertices always reside on that major axis. Okay, let's try one more of these. So I've got negative 4x squared plus y squared plus 40x plus 6y minus 95 equals 0. So normally I tell you guys, okay, we're going to group our x's, group our y's, but take note here, the x is actually negative, and the y, x squared is negative, sorry, and the y squared is positive. So this one, it might be helpful if I take the positive, so the y squared, and bring that out front, y squared plus 6y, then I'm going to have negative 4x squared plus 40x. I'm going to add 95 to both sides. Now I need to take out GCF. Well, nothing to take out here. That stays y squared plus 6y. Take out a negative 4. That becomes positive x squared minus 10x. And again, that equals 95. So complete the square on the y's. Half of 6 is 3. 3 squared, sorry, is 9. Add 9 to both sides. Complete the square on the x's. Half of 10 is 5. 5 squared is 25. But we're not really adding 25, and we're not adding 100. We are subtracting 100 because it's negative 4 times 25. So that means I need to subtract 100 on this side. Okay, that's the hard part. Now I'm going to factor this, so that's going to be y plus 3 squared minus 4. That's going to be x minus 5 squared equals 95 plus 9 is 104 minus 100. That's just 4. Now what I can do is divide both sides by 4 to get my standard form. Y plus 3 squared over 4 minus x minus 5 squared over 1 equals 1. There's my standard form equation. Before I make a sketch, I'm going to take a look at this and say, oh, it's y squared minus x squared. That means it's going to be an up-down hyperbola. Now we're going to get our 3 pieces of information. Center, x pole, y pole. We just have to be careful here. the center, remember, is going to be the x comma y. So it's the opposite of this, which is 5 comma negative 3. Your x pull always comes from the x fraction. So that's going to be square root 1, which is just 1. And the y pull always comes from the y fraction. So it's square root of 4 or 2. Center is 5, negative 3. 1, 2, 3, 4, 5, negative 3. X pull is 1. Go 1 in each direction. Y pull is 2. Okay, so now what I'm going to do is make a rectangle using those midpoints. And from there, I can sketch in my asymptote line. So follow this slope. Looks like it's 2 over 1. Let me scroll up a little bit here. Next, look at your thumbnail. All right, it's an up-down hyperbola. So that means that's going to be a vertex there. We'll call that V1, and that's going to be a vertex there. There's V2. So sketch this in approaching the asymptotes, but never intersecting them. Same thing down below. Okay, so now I've got the coordinates of the center. That's one of the key pieces of information we need. Now let's get the vertices. So V1, what's that? 1, 2, 3, 4, 5, negative 1. Makes sense, right? Using your center and your x pole. Sorry, y pole. V2 is going to be 5, 1, 2, 3, 4, 5, 5, negative 5. Again, that makes sense using your center and your y pole. Now, equation of the asymptote lines. Again, it doesn't really matter what order you find this stuff in. You just have to make sure you list it all. The asymptotes will be y plus 3 equals plus or minus y pull over x pull times x minus 5. Basically, those two equations represent the asymptote lines. Right? Here's that point that's on both lines, and then this would be positive 2 over 1, and this would be negative 2 over 1 for your slope. And the last thing we're going to get is the foci. Sorry, I'm scrolling so much. That equation is going to be c squared equals a squared plus b squared. Looking at your original equation, there they are, 4 and 1. Already squared for you. So that's square root 5. C equals square root 5, which is approximately 2.1. So for graphing purposes, I go just beyond the vertex. So that's 2 away. That's close enough. I'll call that F1. Down below, just beyond the vertex, there's F2. So again, how do I get those coordinates? This distance here from the center to that focus is square root 5. So what are we doing with it? We're taking the y coordinate and we're adding that c value to go up. So it's going to look like this. To get that one, we're taking that y coordinate and we're subtracting the c value because we have to go down. So we start with the center, add the c value to the y for one, subtract the c value from the y for the other. So I don't even need to look at my graph. Where am I? There I am. Sorry. So F1 is going to be the center x coordinate, negative 3 plus radical 5, and F2 is going to be the x value, 5, and then negative 3 minus radical 5. That's all the critical information you need for a hyperbola. Standard form, the center, coordinates of the vertices, coordinates of the foci, and the asymptotes. Okay, so on the exam, you need to know to include all of that information. In example 3, I want you to find the equation of the hyperbola given the vertices are 0, 4 and 0, 12, and the foci are 0, 0 and 0, 16. Now, we really should be able to do this without making a sketch, but I'm going to be visual for this first example and show you how we do it. So to find the equation of the hyperbola, first of all, I need to understand, is it left, right, or is it up, down? Because this one, x squared would be positive, and this one over here, y squared would be positive. So I think you can tell 0, 4, 0, 12, For your vertices, it's going to be up, down. So I know going in, it's going to be a y minus something squared over a squared minus x minus something squared over b squared equals 1. What do we need to get first? We need to get that center. Well, those of you that are good with algebra, you can understand that the center is going to be exactly in between these two. So I need the midpoint. We don't really need to use a midpoint formula because notice I give you very easy coordinates to work with. Both x coordinates are 0. One y coordinate is 4. The other one is 12. So basically I need the number that's between 4 and 12. Or you could just take the average of those two. 4 plus 12 is 16. Divided by 2 is 8. So my center is going to be 0, 8. As I talked about, I know the hyperbola looks like this. So I can actually start the equation. It's going to be y minus 8 squared over something minus x minus 0, or just x squared over something equals 1. So what do we need here? In my equation, you need to understand what goes under that is the y pole squared. What goes under that is the x pole squared. This is where it might be helpful to be visual. So I'm going to take this information, I'm going to put it on a coordinate plane down below. All right, so my vertices are 0, 4. 0, 1, 2, 3, 4. There's one vertex. The other one is 0, 12. So 5, 6, 7, 8, 9, 10, 11, 12. There's V2. All right, I know it's got to look like this. I don't need a perfect sketch. I just want a visual. I know my center is 0, 8. 1, 2, 3, 4, 5, 6, 7, 8, right in the middle. Well, one thing that's easy to get right now is this distance. That is your y pull. The y pull is 4. So y pull squared is 4 squared. That's 16. Okay, super. Well, it doesn't give me any information on the x pull. Remember, what we would do is we make this rectangle and our asymptote lines, but it didn't give us any of that information. But what else did it give us? The foci. 0, 0, and 0, 16. So let's throw those in here and see what this looks like. My foci, 0, 0, and 0, 16. 12, 13, 14, 15. Okay. What does that give us? Remember, the distance from the center to the focus is c. And I've got this equation that involves c. C squared equals a squared plus b squared in a hyperbola. So I can count that distance. That's going to be 8. Okay, so I've got 8 squared equals. The other thing we know is that the y pole is a. So that's going to be 4 squared plus b squared. B squared in this case is going to be my x pole. So I'm just going to do a little algebra here. 8 squared, what's that? 64. That's 16 plus b squared. Subtract 16 from both sides. Now here's the nice part about this. I don't really care what b is because I really need b squared. I think this gives me 48 equals b squared, which happens to be the x pole squared. I don't actually have to solve it for b because I know the denominator of that equation is going to go 48. And there's the equation of that hyperbola. Okay, let's try another. Find the equation of the hyperbola with the center at 0, 0, a vertex at 5, 0, and the slope of the asymptote lines at plus or minus 12 over 5. Okay, so center is 0, 0. All right, so it's going to be x minus 0 squared, y minus 0 squared, or just x squared and y squared. I need to get an idea, though, is this going to be a left-right hyperbola or an up-down? So I'm going to make a quick thumbnail sketch here. Center is 0, 0. One vertex is 5, 0. That's a vertex. So if that's the center and that's a vertex, I know it's going to be a left-right. Okay, I know that one's going to come in here. I don't really need that distance. So it's going to be x squared. Let's do that right here. X squared over something minus y squared over something equals 1. Again, the reason I know it's this, x squared minus y squared, is because it's a left-right. So what do I need to find? I need to find the x pole squared. And here I need to find the y pole squared. Well, we already have the x pole. That's the center, that's the vertex. There's your x pole. 5. So that's 25. So now I have to use the slope of the asymptote lines, plus or minus 12 over 5. So remember, this fraction is equivalent to the y pole over x pole. Now the thing is with the slope, they could simplify this. So in this case, it's kind of easy, but what we actually need to do is we need to create a proportion. We need to take this slope, 12 over 5, set it equal to the actual y pole, which I don't know, over the actual x pole, which is 5. So in this case, it's pretty easy to see that the y pole is going to be 12. If, let's say, this fraction here was, I don't know, 24 over 10, you'd have to cross multiply and figure out what that actual y pole is. But in this case, the y pole is 12. 12 squared is 144. And there's the equation of that hyperbola. Okay, one more, last one. Find the equation of the hyperbola with the center at 4, 1, a focus at 4, 6, and a minor pole equal to 3. All right, so again, I don't know if it's going to be an x squared over something minus a y squared over something equals 1 or the other way around. So I want to make a quick thumbnail sketch. Great. All right, so the center is 4, 1. Let's do that over here. 1, 2, 3, 4, 1. There's my center. A focus is 4, 6. 4, 2, 3, 4, 5, 6. Remember, that's the focus. That's not the vertex. Well, it doesn't really matter. I understand that my hyperbola has to do this. All right, there's my center, there's your focus. The other piece would look something like that. So it's an up-down hyperbola, which means y squared is going to be positive. All right, and I know that's my center. So I can start the equation. y minus 1 squared over something minus x minus 4 squared over something equals 1. Okay, so what's going to go under here is the y pole squared, because that's the y fraction, and under there is going to be the x pole squared. Well, I don't really know either one of them yet, because I know this distance, but that's not the y pole, that's c, all right, which we'll be using in a second. But notice here it says the minor pole. With this is called the major pole, even if it's shorter. It's called the transverse axis. So the minor pole is going to be the opposite of that. So in this case, the minor pole represents the x pole. So the x pole is 3. 3 squared is 9. 9 goes under that fraction. So now I need to incorporate c. All right, the distance from the focus to the center, all right, is 5, so c equals 5. This x pole right here is actually b, even though it might be bigger, I don't know yet. But what we're going to do is we're just going to plug into this formula for c squared. In a hyperbola, it's a squared plus b squared. So this will be 5 squared equals a squared plus b squared, which is 9. 25 minus 9, what's that, 16? Equals a squared. And again, I don't really care what a is. I just need to know that a is the y pole, so 16 is the y pole squared. That goes there. And that's the equation of that hyperbola. Okay, that concludes day 7, guys. Please reach out if you have any questions, as usual. Thanks a lot for watching, and we'll see you guys in class soon.